what we see here is the beginnings of a gas thermometer, and I'll show you how this is constructed. I have a piece of clear plastic tubing. It goes through a soft drink cap. You won't be getting a soft drink cap. It doesn't work as well because it's hard to seal, even with caulk. You'll get a rubber stopper instead of a cap, but the same principle is going to apply. Okay, and then we have another tube. This tube is inserted into this tube, and we have sealant around the tube, and hopefully what we get here is going to work. Now I put the cap onto the bottle. Now I have this. Now what I want is I want some fluid in here. So I'm going to take the bottle and I'm going to dip this end of the tube into a container with some colored alcohol. And I'm going to squeeze the tube a little bit, and squeeze a little bit more, a little bit more. There we go. Now I get a pretty good amount of liquid in here. Actually that's too much, so I'm going to pour some of it out. Okay. Now I got that again by putting this in here, squeezing the tube, because when I squeeze it, we create a partial vacuum and so forth. We'll talk about the pressure aspects as we go through the course. But you see now that we have a U tube, comes down and makes a U, and we have liquid between here and here. Then we're going to seal off this end of the tube. Okay, and I'm going to do that just by putting my thumb over it just to show you what happens. Okay. Now, when I squeeze the bottle, you can see the liquid going up and down according to the pressure in the bottle. So that this thing in some sense responds to the pressure, and we'll worry about the details of that later. I'm going to dump this back out and show you one that I've actually sealed. This apparatus has the tube sealed at the end. Now you notice there are some air bubbles, or there were, but if I bring the thing into a U shape, the air bubbles disappear. Now this end of the tube is sealed, top end. Now whoever made this apparatus made a mistake. The top end of the tube is up here, and it's off of the scale on which I'm trying to measure things. Now let me explain to you how we make this measuring device. I've simply scotch taped the tube to this piece of acrylic, this plastic, and on the acrylic there's a copy of a meter stick that you're going to get in your kit. So what you'll get is you'll get a piece of acrylic in one of these, and you're just going to scotch tape them together. Okay, now we've sealed the end of the tube, so we have a partial vacuum here. Now we notice that as we raise and lower the tube, and I don't know if you're going to be able to see that on the camera or not, but as we raise and lower, not the tube, but the bottle with relation to the measuring device here, the reading here goes up and down a little bit. What we're going to be interested in is the length of the air column. The air column, let's see if I can get this into the picture. The air column starts here and ends up here where the tube is sealed at the end. Now we're going to use this actually as a means of measuring temperature. Right now the system is at room temperature, and I notice that when the tube is at the same height as the middle of the bottle, I've got a reading of 6.5 centimeters on here. Now, I take my thermometer and put it into some hot water and get a reading, which I'll be able to convert to a Celsius temperature very easily, especially if we use the computer calibration. Then I immerse the bottle, and we see that the pressure in the bottle is obviously rising because liquid is rising in the tube. Now I'm careful to try to get as much of this bottle immersed as possible. I'm going to turn it over a little bit, try to get even a little bit more of it immersed. Okay, when the tube stops rising, we're going to take a reading, and that will allow us to determine the length of the air column that results from the water being, from the air being at a temperature that's equal to that of the water. When the column stops rising, if the bottle is completely immersed, then the temperature of the air inside the bottle should be very nearly equal to the temperature of the water. And we can, of course, then repeat this. We can dip the bottle or lower the bottle into ice water. Now, being careful to keep the level the same, and also being careful to let the bottle come back to room temperature. We're going to empty the bottle. We're going to take the cap off the bottle. We're going to let air circulate. Warm air rises, so the warm air will come up out of the bottle. The cool air will replace it. And we'll wait 15 minutes or so until the bottle comes back to room temperature. Then we're going to repeat the whole procedure with ice water.